Hello again. Today what we're going to do is we're going to talk about interior and exterior angles, right? So similar to what we were talking about last time with adjacent and vertical angles, we talked a little bit about corresponding angles and stuff like that, right? Interior and exterior angles are pretty similar, well, related to what we were doing at the end of last lesson. So first off, interior angles are angles that are between the lines. Right, if I was looking at the angles between lines M and N, we'd be looking at 3, 4, 5, and 6, right? They are on the inside of the diagram. If we're thinking about exterior angles, they are angles outside the lines, right? So in this case, we'd be looking at 1, 2, 7, and 8, right? So they're on the outside of the two lines. And that's really all there is to those definitions, right? So then we can talk about the alternate interior, alternate exterior, and same side interior, right? So there's a lot going on with these. So alternate interior angles. Let's talk about those first. I'm going to zoom in just a little tiny bit, make things a little bit easier to see. So for alternate interior angles, right? Alternate means like opposite, right? It's like well, maybe not opposite, but just like opposite sides of something, maybe. You're on alternate sides. So if we're talking about alternate interior angles, right, they need to be on different sides of the transversal in the middle, right? So that line T is kind of splitting us into two halves. So if I'm looking at alternate interior angles, right, we'd be looking at angle 3 and 5 would be alternate interior, right? Because they are on the inside, right? And they are on opposite sides of that transversal, right? Alternate sides. Right. I could also be talking about angles 4 and 6. Right. Those are also both interior and they are on alternate sides. Right. So alternate interior angles would be those ones like in red and blue. Right. We're talking about alternate exterior angles. Right. Same kind of idea except they're on the outside. If I was looking at angle 1, which is on the exterior, the alternate exterior angle to it is angle 8, right? It's on the opposite side of the transversal, right? But it is still on the outside. So 1 and 8 are a pair of alternate exterior angles. And then last but not least, if I'm talking about 2 and 7, those would also be alternate exterior angles, right? Same side interior angles is the only other one we got to talk about. And unfortunately, I don't really have a great way to show those without kind of messing up the color scheme of everything else, but I'll do my best. So the same side interior angles, right? They're on the same side of the transversal and they're on the interior, right? So like 4 and 5 would be same side interior angles. What color haven't we used? Let's use like salmon color. 3 and 6 would be same side interior angles, right? They are on the same side of the transversal. The only thing is that, that's it, right? That's all we really got to say about them, right? So we've got a parallel lines theorem for these, right? So, in these diagrams, or in this diagram on this page at least, M and N are not parallel to each other, right? Those angles aren't necessarily going to have any sort of special relationships between them, right? But if the lines were parallel, then we can say quite a bit. So if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Right, and again, remember the symbol for congruent is that equal sign with a little squiggle above it. That means that they have the same measure, right? So the alternate interior angles would have the same measurement to them. The alternate exterior angles would also be congruent. Right, and again, this is if the lines are parallel, right? And if the lines are parallel, last but not least, the same side interior angles are not congruent, but they are supplementary. All right, they add up to be 180 degrees. Right, so that's only if the lines are parallel, right? If the lines are not parallel, you cannot say any of these things for sure, right? It's kind of tricky sometimes. We've got a couple theorems here, right? If the alternate interior angles are congruent, right? Say you know it by some other way, then the two lines forming them are parallel. right? So this is kind of taking this thing we just finished writing and saying it in reverse, right? If the alternate interior angles are congruent, and you know that some other way, then the lines have to be parallel. Same thing for the alternate exterior ones, right? You can read through it, but it's actually just the same thing all the way through, except it's talking about the exterior ones instead of the interior ones, right? So, third theorem we got here, or I guess this is the fourth one. If the two lines are parallel, then the same side interior angles are supplementary. Right, and again, like I mentioned in the last lesson, some of these theorems just end up saying the same things as each other, which is what we've kind of got going on in this case, right? Is that they took everything that we said in one direction and kind of said it in reverse, right? And what these theorems are going to allow us to do is going to help us jump into proofs, right? So we're not going to go too deep into proofs on this one. I'm actually cutting out a page, so you might see us skip from like example 2 to I think it's example 5 or something like that. So we're just gonna like take a brief little dip into these, right, and not get too crazy with them. So we've got 4 different components when we're doing proofs, right? So the first part is the given information. Right, so a proof generally, like especially for all the ones we're doing, will have some sort of information that they give to you right off the start. It's something that you don't have to prove is true. It's just there, right? The second piece is we need to figure out what we are proving. Right, so obviously you need to have a goal in mind, right? You're doing this proof for a specific reason, right? You're trying to prove something in particular. A lot of times for geometry, there's going to be some sort of a diagram or a drawing to help us organize our work so that we can kind of, relate all these different, like angle 4, we need to know where that is in relation to angle 5, right? Because the numberings could be different from diagram to diagram. And then last but not least is the proof itself. Right, that's where we're going to be making conclusions. If you look a little bit further down this page, we're going to be making conclusions and we're going to justify why those conclusions are true, right? So a proof is kind of like it's a really like an important mathematical thing to be able to do. You are saying these things are true about this geometric diagram and you are proving why they are true. Right? It's not just like because it looks like it is, right? You're actually using theorems or postulates and saying like, this is why. I know that this has to be true because this is how this works, right? So for this first one, we're going to prove that the alternate interior angles are congruent in this diagram, right? So we have our given info, right? That's the first thing. We are given that M is parallel to N, right? What I would suggest is anytime you have given information like that, look over at your diagram and make sure that that information is marked on your diagram. So I don't see anything that says that M is parallel to N. So I'm going to put these little like parallel arrows on it. Excuse me. And now it's showing that M and N are parallel to each other, right? That's showing our given information. It also has what we're proving, right? We're trying to prove that 6 and 4, those two angles are congruent to each other, right? That they have the same measure, right? So we can't just jump straight to it, right? As you can see, we got some different steps to do. What we're going to be doing are these types of proofs are called 2-column proofs because they have 2 columns, right? So you have this one column where your conclusions are, this one column where your justifications are going to go, right? So as we go through these, right, a lot of the times I'll have one part filled in and we'll just have to try and figure out what fits in the other part. Maybe at some point this trimester, not sure quite yet, we might get into some where I'm going to have you try and, figure out what everything down here is going to be. It's not going to be filled in at all, right? So let's just give this one a go. So my first conclusion is that M is parallel to N. And the first justification for that is pretty easy, thankfully. Right? The reason that we know that M is parallel to N is because they told us so. So all we would say is that is given. All right, so a lot of proofs will start off by just saying, like, this is your given information. There you go. It's given. That's it. That's all you got to say there. Then we move on to something, things that are a little bit tougher, right? Because this is where we actually have to use our brains. Oh, man. What a bummer. So we have to show somehow, like, why are 6 and 2 equal to each other? So if I'm looking at 6 and 2, those ones that I just circled there, what we're trying to do is we're trying to think about why would those have to be the same? Like, what's the relationship between angle 6 and angle 2 that makes that work that way, right? And I'm going to be honest with you, some people might want you to write like, oh, this is the blah, blah, blah postulate or the blah, blah, blah theorem, right? I'm okay if you just like tell me what the relationship is, right? Because that's the most important part here is like what's going on between them. So 6 and 2, if I'm looking at those on this diagram, those are corresponding angles, right? So because they are corresponding angles, right, and the lines are parallel as was given, right, then that's how we know that they are equal to each other, that they are congruent, right? So after we get 6 and 2 to be the same, right, what I might suggest again is that you've proven that, right? You've put that in your proof. You can put this little marking in there to show that, like, all right, I know that these are the same, okay? After that, we've got 2 is congruent to 4. All right, so I'm going to do these ones with a little bit of a blue bit there, right? Actually, we got the highlighter thing. How are 2 and 4 in that diagram supposed to be the same? Right, and again, just think about what the relationship is between them, right? If I'm looking at 2 and 4, those highlighted blue, right, those two angles are vertical angles to each other. Right? Vertical angles are always going to have the same measure, right? So because I know that they have the same measure, what I can do is I can now fill that in because it matches up with 2. I should put that same arc marking in there. And last but not least, we're trying to say somehow that 6 and 4 are equal to each other. So you might be thinking like, oh yeah, well, we just learned about this, right? They're alternate interior angles, that's why. But that's what we're trying to prove, right? So we can't use, what we're trying to prove as our justification, right? That's kind of a no-no. So another way that we can kind of get there, and you're gonna have to go with me for a little ride here, right, is we can use this thing called the transitive property, right? So the transitive property is working kind of like this, right? Let's talk it through. We showed that 6 is congruent to 2. Oops, I don't know why that went so extra dark there. So 6 is congruent to 2. That means that they are equal to each other. We also proved that 2 is congruent to 4, right? So what's going on here is that if 6 is the same as 2 and 2 is the same as 4, then 6 has to be the same thing as 4, right? They've got 2 as kind of like that stopover in between. So the way that I, first off, let's write in transitive property. All right, so transitive property, again, is basically just saying, like, if I have kind of like a stopover that's showing that all of these things should be equal, then they are equal, right? The way that I like to think about it is the word transitive makes me think of like transit, like traveling. So if you imagine like going on a plane, like say I was going to Walt Disney World, and I had a layover in Baltimore, right? Like I had to stop and change planes or whatever, right? So I'm starting, let's use this. I'm starting at the jet port in Portland, and I am going, and I had to stop in Baltimore, right? So from Baltimore, I'm sticking around there for a little while, and then from Baltimore, I'm now traveling to Florida, right? At the end of the day, I still went from Portland to Florida, right? I just had a little stopover in between, right? I'm still traveling to the same place from the same place, but, I just had to stop somewhere in the middle, right? So whenever we have something kind of like this, we can use the transitive property. The more technical way of talking about it, which I'll write in here real quick, is that if A equals B and B equals C, then A equals C, right? So if two things equal the same thing, then they equal each other, right? Another way to think about it, if this is helpful, is imagine shoe sizes, right? Say that me and another math teacher in the building have the same size shoes, right? So we could share shoes with each other. Say that that other math teacher and a social studies teacher had the same size shoes. They could share shoes. Well, then me and that social studies teacher could also share shoes, right? We would all have the same shoe size because we're all equal to each other, right? So it works out that way as well, right? So we've now done our very first proof. Let's go. Not too bad, right? We're going to do one more together, and then we'll kind of keep moving on. So we're going to prove the alternate exterior angles theorem, right? So again, we've got some given information. I'm going to make sure I mark it on my diagram. We are given that 5 is congruent to 3, right? Oops. So I'm going to put these little arc markings in there. So we know that 5 and 3 are the same. We want to prove that the lines are parallel. So that's kind of tough, right? So for 5 and 3 being equal, right, they just tell us that, right? That is our given information, right? Then we start working on the rest of it, right? Now we're trying to figure out, all right, how can I say that 3 and 1 are the same, right? So just think about what type of angles 3 and 1 are, right? If I'm looking at 3 and 1 on that diagram highlighted in blue, then what I'm seeing is that they are vertical angles, right? And because they're vertical angles, you know, that just means that they have to be the same, right? So what I can do is zoop, pop a little marking in there, right? Let's darken those up a little bit, right? After that, how do I know that 5 and 1 should be the same, right? Well, we actually just talked about it. We have the transitive property, right? If 5 is the same as 3 and 3 is the same as 1, then that means that 5 has to be the same thing as 1, right? We just got that little layover in between, right? So we can use the transitive property here. All right? And then last but not least, right, this is probably the trickiest part of all, is how can we now say that those two lines are parallel to each other, right? So let's take a look at what we just finished with that third step there, right? We're saying that 5 and 1 are congruent to each other, right? That they have the same measure. So what I'm going to do is let's take a look at what 5 and 1 look like on the diagram, right? 5 and 1 look like that, with the highlighted ones there. And if I'm trying to think about what the relationship is between them, right? They are corresponding with each other. And if they're corresponding and have the same measure, then that means that the lines have to be parallel, right? That's something we talked about last lesson, is that if you have corresponding angles that are the same, then the lines are parallel. All right, so we'd say just that they are corresponding angles. All right, so really what's going on with these proofs, as far as we're concerned for now, is we're just trying to figure out what's the relationship between the angles. Sometimes you might have to use something like the transitive property, which, you know, if we ever need to talk about one of those like we just did here, I'll talk us through it. And that's really all we need to do for proofs, right? So like I said, we're not going to dive too deep into them right now. I do want to keep on moving on, right? So we got a couple more problems and then we'll be done for this one. So in this one, we have some measurements which are given to us with variables and everything else. We want to solve for x and then find the exact measure of the top right interior angle, right? So we want to figure out what 14x minus 4 actually is. So to solve for x here, right, what I need to do is I need to think about, all right, what's going on with these two angles, right? I have all this algebra going on, but I don't know what's going on geometrically. So geometry-wise, right, these are alternate interior angles, right? They are on alternate sides of that transversal, and they are both on the interior, right? These little markings over here are telling me that the lines are parallel to each other, right? So that means that these angles are actually equal. So I can say that 14x minus 4 is equal to 12x plus 8. Right? What I'm going to do here is I'm just going to go ahead and I'm going to solve this out and figure out what x is. So I'm going to move all my x's to one side. So I have 2x minus 4 equals 8. I'm going to move that 4 to the other side to move it away from where the x's are. We're going to get that 2x equals 12. And then we need to get rid of that 2, so we're going to divide by it on both sides. So x is going to equal 6. Right? So x is equal to 6. Hooray, we're done, right? Nope, they still want us to figure out the measure of that top right interior angle, which was that 14x minus 4. So I'm going to do, I'm going to take 14 times that x we just found, minus 4. All right. So 14 times 6 should give us 84. And then minus 4 brings us to 80. So 80 degrees is what we're looking for there. All right. And that's it, right? When you're working on these types of problems, as long as these lines are parallel, as it shows where I just kind of scribbled over, right? As long as those lines are parallel, the alternate interior, the alternate exterior are equal to each other, and the same side interiors are supplementary, right? Try out this one, right? We've got two parallel lines, right? Because that's what those markings show there, right? See if you can figure out what x is and solve to figure out the bottom right angle there. Right, so hopefully you paused and gave that a shot. Let's give it a go. So to solve for x, right, I can just set these two things equal to each other, right? 15x plus 5 is equal to 17x minus 3. All right. So I'm just going to solve this out like I would any old equation. All right, I'm going to move all my x's to one side. Oops, and I guess we're going with the small pen now. So I'm going to subtract 17x from both sides. We're going to get negative 2x plus 5 equals negative 3. And if you're looking at your own work and you moved your x's to the other side, don't panic, right? You still might end up being right. We can move our x's to whichever side we want. All right, so stick around. See if we end up in the same place at the end of all this. All right, so negative 2x equals negative 8. We're going to divide by negative 2. And x is going to equal 4. All right, so now that I know that x is 4, right, what I'm going to do is I'm just going to plug that back in, figure out what that bottom right angle is, right? 17x minus 3. So I'm going to 17x, which is now 4, minus 3. 17 times 4 should hopefully give us 68. And 68 minus 3 is 65 degree-roonies. Right? And that's what we're trying to get to. Right? So when it does ask you for, figure out the measure of this angle, am I going to dock you every single last point if you forget to do this last little piece over here where you plug it in? No, I'm not gonna say this is trash, do it all again, if you get to x equals 4, you're basically there. Just try not to forget this last step, right? It is part of the problem, right? So make sure you try and finish the whole problem, right? Last one, we want to solve for x and then find the exact value of the top angle here, right? So we want to figure out the measure of that one afterwards, right? So to solve for x here, right, it's a little bit different, right? They are same side interior angles, which means that they aren't congruent, right? They're supplementary. So remember last time we talked about supplementary, they add up to 180. So what I'm going to do is I'm going to say 10x plus 10 plus that other angle, which is 13x plus 9. All of that together equals 180, right? So I'm going to zoom in a little bit. What we're going to do is we're just going to solve this out, just like we normally would, figure out what x is. So first things first is I've got some like terms I can smush together. All right, so 10x plus 13x is 23x. 10 plus 9 is 19. All right. After that, what we're going to do is we have all our x's over on the left side. I'm going to move my other numbers, namely that 19, over to the right. All right, so we get 23x equals 180 minus 19 is going to give us 161. I'm going to divide by 23 to get rid of that. Oops. And then x is going to equal, what's that going to come out as? 7. All right, so x is equal to 7. Cool. Almost all the way there. All I got to do now is plug it back into that top angle there, which is 10x plus 10. So if it's 10 times the x we just found plus 10, 10 times 7 is 70. 70 plus 10 is 80 degrees. Right. So something I haven't actually remembered to talk about on the last couple is that when you figure out an angle like this, right, Like if we're trying to figure out what the measure of this angle is and we say, oh yeah, it's 80 degrees, right? Make sure that your answer makes sense, right? If I ended up with something like, oh yeah, this is 420 degrees, huh? You know, that's not going to make sense, right? So even if we got an answer like, oh yeah, this is 205 degrees, right? That still doesn't work, right? That angle is around 80 degrees, right? That's a plausible measurement for that, right? On this one up here, if we figured out this angle, 65 degrees, all right, sounds pretty reasonable. It's definitely not like 2 degrees, right? And the diagram doesn't always tell us the truth, but it should kind of, seem sort of all right, right? That one seems like it could be 80 degrees there, right? As for now, that's all I've got to talk about, so I'm going to let you go. See you next time.